Almost all the exports that go pouring out of Britain, and on which our very survival as a major nation depends, have one thing in common. Somewhere behind them is the knowledge and skill of the qualified engineer. Without such men, we would get nowhere in the world of today, for there's hardly a thing we make that doesn't involve their know-how at some time in its making. The civil engineers who build, the chemical and electrical engineers, the production engineers who design the assembly lines, all these have their important part to play. But it's the trained mechanical engineer whose work has the widest range. He's the man who designs the machines, who researches the behavior and shape of things, and using the tools he gives them, naval architects can study the pitch of a trawler in a rough sea. Hence his handiwork in the test tank at the National Physical Laboratory on the outskirts of London. There seems no limit to the range of the problems he tackles. Here is a scale model of the post office radio tower to be built in Birmingham. How will it stand up to violent storms? The aerodynamic engineer will set up his model in a wind tunnel, and the delicate instruments designed by the mechanical engineer will give the structural experts an exact record of the stresses and strains the tower will face in a 90-mile-an-hour gale. More than 3,000 youngsters graduate in mechanical engineering in Britain every year. There's room for more, many more, and room too for the very advanced men who go on to the higher degrees. What are the interviewers looking for when the young men, and sometimes young women, come up as candidates for admission to Birmingham University, one of the big mechanical engineering training centres? More than anything else, they say, they want young people who want to create things, who want to be in charge of the craftsmen and technicians who do things. Most of the youngsters come from grammar schools after chalking up 5.0 and at least 2 A levels. Once enlisted, the new students start an intensive 3-year course in a wide range of subjects. Training of this sort costs the country £2,000 a year per student, and from the country's point of view, it's cheap at the price, for we need them badly. As they move forward, so they start work on practical engineering. Here, a group works on a machine that they designed themselves. They're finding out how different materials react to the knocks and bangs of everyday use. Special instruments produce their own record of the shock of the impact. This machine visibly shows up the vibrations to which, say, a panel in a car might be subjected, and indicates where the stress might come. By studying it, the research men can see how the material will stand up to its job. Here is a photographic way of studying how materials behave when they're actually under stress. We might say that the effect is to freeze the stress and then to project its pattern onto a viewing screen. The engineers are getting into the heart of a piece of perspex after it's been cut. The coloured streaks show what has been happening inside the material. In all this training, the drawing board is vital. Drawing leads to design, the engineer's main creative activity. In the new town of East Kilbride, near Glasgow, is one of the places where important mechanical engineering research is carried out. About 300 qualified men work here in Britain's National Engineering Laboratory. Many of them came through training courses like the one at Birmingham. Some started off in industry straight from school and then qualified by studying in their spare time. East Kilbride has facilities for the most advanced research. These machines are helping in the study of the way a metal deforms slowly when it's working under high stress and temperature, like the blades of a turbine or even the spring inside a light switch on the wall at home. Elaborate instruments can measure the actual stretch of a metal over a period of years. This sort of research is of great importance in the designing of machinery. There's no pure science about East Kilbride. All the research aims at a practical end product. This is an experimental condenser for turning steam back into water after it's been used to drive machinery. The steam is cooled by cold water tubes inside the casings and flows out from the bottom as water. The engineers are trying to develop smaller and cheaper condensers for ships and for power stations. This is a setup for testing the blades in a water turbine. These blades have been designed by a computer, which also punches out the instructions for the machine tool that carves them into the precise shape. The result is an altogether quicker and more accurate design than could possibly be obtained by conventional methods. In a separate building, East Kilbride's ingenious engineers concentrate on some of the special uses of fluids, which are used here to transmit energy without any mechanical link, such as gears in between. This unit transmits 80 horsepower and is much more flexible than the ordinary gear transmission. It drives this cutting machine much more efficiently than a conventional unit would do. At Melton Mowbray, here's another remarkable field of mechanical engineering research, in which metals are molded into shapes by explosion. This can be applied to all sorts of moldings where it wouldn't pay to build a complete machine tool, and experiments in this field are going on at research stations throughout Britain. The basin-like mold with a piece of metal to be forced into its shape is lowered into a tank. Explosions had to be treated with respect, even by the engineers who organize them. The explosive charge is fixed on top of the mold. The tank is filled with water to control the force and direction of the explosion. And here's the bowl-shaped end product extracted from the mold, perfectly proportioned, blasted into shape by the force of a controlled explosion. In ultra-modern works like the Post Office Tower now reaching up over central London, many skills combine as the engineers climb upwards into the world of tomorrow. Already, long before it's in use, everything is known about the tower. It holds no secrets, but many marvels. It has been tried and tested on the drawing board and in the wind tunnels. It's a triumph of the professional engineers of today, successors to such pioneers as Stephenson, Watt and Brunel, who helped to found the modern greatness of these islands.